Hey guys, today I'm doing a power jack repair on a Lenovo Ideapad Gaming 3 laptop. This is one that came in with a really loose jack where you plug in the power cord. That jack is physically broken and it needs to be replaced. So the first part of the video here is going to be me doing the teardown. And the laptop does need to be completely taken apart to the motherboard to access the power jack. And the Ideapad Gaming laptop uses a soldered on DC jack, so there will be a desoldering and resoldering of a new one on. And here I'm just removing all the bottom screws so I can take off the bottom plate. And I'm just using a thin guitar pick here to get in between that chassis and the bottom plate. And you can just kind of pry it up a little bit and that should come off. And this is kind of tricky sometimes. You just kind of have to work it around over and over again until those clips come off. And what I'm doing with my one hand there is I'm kind of applying pressure on the side that I did get up and then continuing to go around with the guitar pick. But you never want to force it. You can easily break something if you try to just rip it off of there. Now that the bottom cover is off, the first thing I typically like to do is detach the battery. This is good because you want to make sure that there's no power to the laptop when you're doing the disassembly. If there were power to the computer, theoretically you could break something or discharge, I'm not sure, but it's always good just to unplug that battery first as part of the removal process. If the computer is off, in my opinion, nothing's going to happen, but you just never know. As a repair technician, sometimes you'll get a computer in that's been put to sleep or something like that, so it's always good just to remove the battery and detach it first. And there I just detached the hard drive cable. It's a little flip up lock style connector where you flip it up and the ribbon cable will come out. And then I'm just going to remove the hard drive next. There's 4 screws that hold that caddy into place. And now once that hard drive is removed, the battery can come out. I think it was holding it in just slightly, obstructing it from coming out. And right here I'm just detaching the stickiness of that CMOS battery, because when the motherboard comes out you're going to have to take that CMOS with it. I don't like to detach the CMOS battery because I don't want to lose the BIOS settings, but it does have to be pried up a little bit so you can remove the motherboard. And here I'm just removing the SSD drive out of there. That might not necessarily have to come out on some models, but I believe with this one it's kind of obstructing the keyboard and the touchpad cables, so it needs to come out. And here I'm just detaching the speaker. I try to get one side of the flathead on the connector and my finger with the other side of the connector. And the backlight and keyboard and touchpad cables are all the similar flip-up lock style connection where you just flip the connector that's holding it down up and then you can remove the cable. The connector never comes off though. That's a common thing that people break, is they try to remove the connector, but it's just a flip up, flip down. And here I'm going to detach the fans and the wireless cables. And now I'm just going to start to remove the heatsink screws here and the fan screws. And once all these screws are removed from the fan and the heatsink, that whole heatsink and fan assembly can come off. And if you're using this video too, you can also use it to take apart the laptop to the point of where you're getting to the fan, and that will allow you to replace the thermal paste on the GPU and the CPU. And right here I'm just removing the ribbon cable, same thing, flip up style lock connection. And I like to flip those connectors that I took out back down just in case, so I don't break something when I'm doing the soldering part. And here I'm just removing, there's a little harness that goes over the DC jack. It's like a little metal shield, and it's got 2 screws, and it's part of the motherboard screws as well, which I'm also doing right here, just removing motherboard screws so the whole board can come out. And now, once all those motherboard screws are removed, you can carefully pry up that motherboard. As you can see, this broken jack is very, very broken. There should be a little plastic square in there that's now missing. So the next step here is going to be the desoldering, and this is what I would call the most difficult part of the repair. To do the desoldering, you need a good quality soldering iron. Right here I like to use some flux to get everything flowing. And in the case of this Ideapad laptop, it's also going to need to be using the hot air soldering station to remove it too. I found that, especially with these later laptop models that have been made in the last few years, they're just harder and harder to just purely desolder with an iron. These connections are getting smaller and smaller, and they're just getting very difficult to desolder alone with a soldering iron and braid or a pump or whatever you're using. So my technique is I like to add some flux, I like to add some solder, and those 2 things get the through hole heated up nicely and get the solder flowing. And then next I'll be taking the desoldering braid to remove the solder that I put on there and the existing solder on there. So here I'm just going to take that desoldering braid and just try to get as much of that solder out of the through hole as possible. This is a really tedious process, but sometimes if you don't get enough solder on that wick the first time, you want to repeat the process of adding flux and adding solder and trying to do the desolder again. And I solder at roughly 750 degrees. I'm using a Hakko FX888D soldering station with a smaller chisel, what it's called like a chisel tip. It's almost kind of like a flathead screwdriver. I feel like that chisel tip is nice to get in between these rectangular through holes. Seems to heat up the hole the best and works much better than the pointy style that a lot of these soldering irons come with. That pointy style just really can't get that hole heated up enough to get the solder to come out. So using that flathead or chisel tip, whatever you want to call it, is much better for doing the desoldering on these power jacks. So here I'm just taking some 99% alcohol and I'm just cleaning up that jack area, getting the flux off of there. And here I'm taking some Kapton tape. The whole point of cleaning up that area is now it's free from flux and grime, and I can put the Kapton tape around the jack area. This is going to keep the components that are surrounding the jack safe while I'm doing the hot air soldering. If you use hot air soldering and you don't have the Kapton tape, you risk breaking or damaging the circuitry around the jack. So that's definitely a must. And this hot air can, literally blow some of those teeny little resistors right off the board if you're not careful. And like I was saying before, that the solder just does not come out sometimes properly with that wick, or the pump, or whatever the case may be. I just cannot get it heated properly to get that solder off like I have, especially with the teeny size of these through holes. And the more I try to solder and solder, the more I risk just damaging the through hole. So I've just found that using this hot air technique of heating the jack up, heating up those solder points, and just letting this jack basically fall out of the through holes when it's hot enough is a much easier tactic than trying to desolder it over and over again. And once you have the jack removed as well, it's much easier to desolder when you're just doing a straight through hole versus when there's that jack inside of the through hole. And this can take quite a while. This, in my opinion, in my experience, it really depends on the thickness of the board and the kind of solder that they used. I've had ones that come off very quickly, and I've had ones that take me 20 minutes plus of just using that heat gun to get the jack to come off. So I think these Lenovo style boards are kind of in the middle. They don't take forever, but they're not quick either, which I think in the video here it's about 10 minutes, give or take, of the hot air soldering before this thing's going to come off. I could potentially bump up the temperature and maybe get the jack to come out quicker, but I don't want to risk damage to the circuitry around there. I want to use a kind of a little bit of a lower temp, so I'm not risking damaging anything when I'm doing this removal process. And I debated speeding up this part, because it is kind of boring and tedious, and you can fast forward to the point if you'd like, obviously, to when the jack is actually removed and when I start doing the rest of the removal process. But I figured I'd just put in the full time of what it actually took, so you get a really good idea of what you're working with instead of me speeding it up and not really knowing what you're getting. And if all this is too much for your guys' tech comfort level, this is a service that I offer for $69 parts and labor. I do a mail-in laptop repair service. So really anywhere you are in the nation, I've been doing this since 2007, you can pack up and send your laptop, and then I'll be doing exactly what you see in the video, just replacing that broken power jack and getting everything up and running again. And this Lenovo Ideapad Gaming 3 laptop does fall under my standard $69 parts and labor. And in my other hand there, I'm holding it with the tweezers. I'm just kind of assessing where it's at. You start to physically feel when that thing is coming loose, so having the tweezers in my other hand, I can see, or feel rather, when it's starting to come loose. And you can also see, if you take a look at the solder points that I'm putting the hot air on, they'll start to get shiny, kind of like solder flowing that you typically see when you put solder on an iron. And right there, you can see it just kind of eventually, over some time, will come off nice and smooth and just come right out of the through holes there. And then all that existing solder is just much easier to remove than what I was trying to do before, and with less potential damage to the through hole, which is great. So now the next step is to remove the Kapton tape and finish the desoldering of those holes. This can also be pretty tricky too, that solder just does not want to come out of there sometimes. So just like before, I'm going to add some flux. Sometimes, depending on the model, I'll add some more solder just to get that hole, everything flowing through the through hole. And that usually makes for an easier desoldering process. But the flux is key here. You can be really liberal with it. You can always just take what I'm about to do with some 99% alcohol and just clean it all up when it's done. It's going to make that solder flow so much easier into the braid. It just makes your life a heck of a lot easier. The solder that you use has built-in flux, and same thing with the solder braid or the wick, but it's just never good enough, I found, to really get in there like you needed to. So after adding some solder and some flux, I'm just going to take that desoldering braid and try to get all that solder out of there. This whole process is, kind of tedious, but you really just have to go over it again and again until that solder comes out of the hole. And like I said, if it doesn't come out the first time, you can reapply solder and reapply flux and try it again. I've had some times where I need to do that up to 3-4 times just for it to finally get all out of the hole. And for some reason, the back pins on these Lenovo motherboards, the far right and the far left, the solder just does not want to come out. And I've just done endless amounts of adding solder and flux, and never really can get out of the hole. So sometimes I have to take a tweezer, the same tweezer I was using for that hot air part. It's got some really sharp ends, and I can kind of push some of that solder through there when it's all warmed up. And it can be really crazy to get that solder out. I don't know what's going on there with the Lenovo's. But see right there, I'm using that tweezer technique. There's just like a tiny bit of solder that just does not want to come out. So you can kind of push it through the hole, and you just need to be extremely careful when you do that. And another technique too is just to flip the board over. Sometimes you can get a better angle on it, or you can get that through hole from a different position. And that can really help too. So make sure you try both sides of the motherboard when you're doing that desoldering. Flux, flux, and more flux. That's what I would recommend. Especially when you're doing the desoldering part. Just more is very helpful. And right there, I'm laying the chisel tip on the side of the chisel, so it kind of makes the tall part of it go directly over that through hole. Or you can look at this, the side of that chisel is going on the hole, and I'm just trying to get that chisel tip, almost indented in the through hole, just to make that solder come out better. Sometimes you can, depending on the size of the through hole, you can go at it from the top with the chisel or the side, but really I try almost all techniques because it's just extremely difficult to get the solder out of these Lenovo boards. And there I'm just going to try to poke it through a little bit. And also when you poke it through as well, it kind of pushes it out to the other side, which makes it able to flip over and then desolder some more. So it makes that desoldering a little bit easier once it's flipped over and that solder is pushed up a little bit. But it just does not want to come out of these holes. It can be, a little frustrating at times trying to get this thing out, but with some patience and persistence, it will eventually come. But just be really careful when you're doing the tweezer trick there. You don't want to damage that through hole. And you only would want to do that if you had just got done soldering that specific hole when it's all nice and warmed up. And now I've gotten to the point where I can try to fit that new jack into there when enough solder has been removed. Just make sure you take note of what side that jack goes onto. If you put it on the wrong side, you'll do all the soldering, put it back together, or attempt to put it back together, and then the case won't go back on properly. So just remember which side it is that you desolder when you put the new jack back onto there, because it should go in its flip side the wrong way. But unfortunately in this case I just can't get it to go in properly, so that means more desoldering needs to take place. The new jack should slide right in there and fit in there pretty easily. You might have to give it a slight push or something, but if it's not going with a small amount of force, then it just needs more desoldering. And you should obviously be able to look at the through hole too. If you can see through it and it's been desoldered properly, but if you still have obstructions in there, that new jack is not going to go in there. Alright, so now I'm going to check it out again, see if I can get that jack to go in there properly. And I think I've determined which hole is not going. Usually it's just one or two that needs a final desoldering for it to properly fit. And it's that pesky corner one. Alright, so it looks like the jack is finally in there properly. And I'm putting that pliers underneath there to just hold that jack steady. If you lay it flat on the desk, sometimes the jack will fall out and the holes will be uneven, or the jack won't be flush with the board. So I like to stick something like that underneath there and make sure that all the jacks are going through nicely and flush. Each one of those through holes is properly through. The last thing you want is a lopsided jack when you reinstall it and then have to do the work over again. So there I'm going to add some more flux to the through holes and start soldering this new one in. And this is what I would call the easy part. Once you have the old jack removed and the new one installed, just simply adding some solder into those through holes is pretty easy. It's really the tear down and the desoldering aspect that makes this hard. So I'm just getting that solder, making sure it flows completely all the way through that through hole onto the other side, making a good connection. And once again, flux, flux, and more flux. That'll really help that solder flow through there. And now I'm just taking some of that 99% alcohol and just cleaning the remaining flux off the board. And this thing's all ready for reassembly and powering it up. This one came out really nice. If I can get the camera to focus here. And we're all set to go. If you guys have any questions, just leave a comment. Thanks, have a good day.